All right, the second part. How much candy can LeBron grab? LeBron James has 4 NBA. Yeah, you know who he is. How many candies can he grab? One of the algebra classes collected the following data. Use the applet to find the line of best feed. Record below. So as you can see on the screen, I already put all of this data in, which you're more than welcome to do it. There is my scatter plot of that class. And what was the line of the best fit? It was, let me write it. You can write on number 2. Equal to negative 49.4. I'm just going to round it up. 41 plus 3.54x. Let's just do that. Okay. All right. Once again, how can I interpret that in terms of the context? The predicted y value was what number of candies? Equal to negative 49.41 plus 3.54 times x. X is the handspan. Okay. All right, number 3. LeBron James had a handspan of 23.5. Use the equation of the line to predict how many candies LeBron can grab. Okay, so LeBron has 23.5, so I'm going to take that 23.5 and plug it into x over here. Oops. So y is equal to negative 49.41 plus 3.54 times 23.5. Let's go ahead and plug it in our calculator. Negative 49.41 plus 3.54 times 23.5. Okay, I got 33.78. 33.78. So what does that mean? That means, according to this line of best fit, he should grab 33.79 candies. Which is interesting, right? Because there's no decimal number of candies. When LeBron visited here in high school, he attempted the candy grab and was able to grab 38 candies. Add this point to the scattered plot. Okay, so what was him again? His handspan was 23.5, comma, he grabbed 38 candies, which you'll like. So put that on our scatter plot with a different color. So 23.5, up there, comma, 38. Somewhere here, 38, up here, can you see? Up here. Okay, there's a LeBron right there. Was this value higher or lower than what you predicted? Well, we predicted 33 candies, and he grabbed 38 candies, so it was a lot higher. By how much? By how much? Well, he grabbed 38 when he was predicted to grab that, so 38. We can't see, can you? 38 minus 33.78 is 4.22 candies. 4.22 candy. And guess what, folks? What will be the distance from here to here? That will be 4.22 as well. Isn't that cool? That's a residual. We're going to call it residual. Residual, not like a trash residual, but residual. Okay? Alright, now I'm going to pause it and then go back to the whole camera. Alright, now it's my turn to measure my handspan. About 18 centimeter. Predict how many candies I will grab. Okay, so my handspan is 18. There's our equation line of best fit. So y is equal to negative 49.41 plus 3.54 times x. And let me take that 18 and plug it into my x. 18 right there. Okay, plug it in. Oops, what I'm going to do, I'm going to just repeat that, but instead of those number, put mine in, which is 18. Oh, 14.31 candies. Okay, so according to our line, I need to grab 14.31 candies. Are you ready? Okay, there's my hand. 2. Let's count 2, 4, 6, 8, 10, 12, 14. Oh my word. 14. Look at that. Look at that. All right. Add this point to your scatter plot. Fine. So mine was what? 18 comma 14. 18 comma 14. Right here. Right there. Was this higher or lower? Just a little bit lower, but not by that much. All right, so I was supposed to grab 14.31 candy, and I grabbed 14. So it was only difference of 0.31. All right. And guess what? The distance between my point and that line over there is going to be 0.31. What is that name again? Residue. Cool. All right. All the key points. Two key points that I want to talk about. Number 1, prediction. So when you have a plus bx, how do you predict? Plug in value for x to predict y value. Right? Alright, key point number 2, residual. So what is a residual? It is the actual measure minus predicted measure. So actual measure is actual how many candies did I actually grab. Predicted was from the equation how much I was supposed to grab, right? So the actual y context was residual higher or lower than predicted for x equal to a number. If point is above the line of best fit, then the residual is positive. So for example, over here, remember with the Lebron, we predicted he was going to grab 33.78 candy, but he grabbed 38 candy. So since the actual was higher, it was above the line of the best fit, we had a positive residual over there. That's what I mean by that. Cool? Cool. Let me fix one thing quickly, just to make sure over here that residue is negative 0.31, because I grabbed less than what I was supposed to. So make sure that has a negative there. Cool. Check. At the end of the semester, math teacher wonder if the student attendance have some impact at the final exam. So similar to what we did on the previous one, there is a line of best fit. Find the predicted exam student for 7 absences. So you're going to take that 7, plug it into your x over here. So y is 90.9 minus 3.5 times 7, which you're going to get 66.4. So according to this line, the formula, a student with the 7 absences should get 66.7 on their final score. Now let's actually see it. One of the students actually had 7 absences at the school. What was that person's final score? 75. So calculate the residual. So residual is actual minus predicted. So the actual score was what? 75. Predicted was 66.4. That makes a residual 8.6. So that means, interpret the residual, that means the actual final exam for the student with 7 absences is 8.6 higher than the predicted amount. Right? So the student actually scored 8.6 points higher than predicted. Wow, I lost handwriting. Alright, for how many students was predicting greater than the actual? So you can look at your scatter plot there and just count how many are above the line of the best fit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I miss anyone? Let's count one time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students. 12 students. Okay. Go back. Over here, when I did mine, that's actually not how you find the residual, as we just went through it. How do you find the residual? Actual minus predicted. Actual was 14. Predicted was 14.31. So it has to be negative 0.31. Make sure, let's change that note on the previous page. Okay? Alright, thank you so much. Now, on to do your 6.3 IP. Good luck.